Fall semester, and not sure. Well, so I can talk loud enough, even if this isn't working. So we're really thrilled to have you here. We're going to have this every week. I'm excited to see, for the first year students, we got a little bit of a stick that you actually have to be here. For the second year students who are attending, thank you. I think you're going to find this really interesting. Every week we're going to have a different engaging speaker. We're starting off with kind of a star and a great lead-in with Levi. It'll be folks from our program, from outside, from other parts of the university, from here in other places here in Colorado, some national speakers as well. So it's a great seminar series. And so I just want to say welcome to all of you, and then I'm going to hand it over to the people who are really running all this, and so I'll give it to Jim. All right, so Jim.
Okay, everybody, the reason why I have this microphone is, first of all, to introduce Professor Perigo, and I also wanted to extend my thanks. Let me tell you a little story before we start. The class in this room seats about 74. We have overflow capacity, and if you turn around, you'll see a room that's ECCR 150. And it is basically a Zoom installation that we're using. We had anticipated or not anticipated the additional second year students, but welcomes everybody. So today we are honored and very pleased to have our first speaker of the semester. There will be speakers all the way up until just before Thanksgiving. As Dan said, we're inviting very interesting folks who will cause you to be annoyed. We are inviting faculty members, some of whom you know, and some of whom will speak in the spring semester. They'll run classes, entrepreneurship, for example. And with that, it is my distinct pleasure to introduce Professor Levi Perigo, and he's going to tell us about something called SDRs or SDNs, or something that defines networks in a complicated way and then adds visualization aspects. Please welcome Dr. Perigo.
Thank you. Okay, thank you. So to start out, welcome all the first years. Where's my second years? Raise your hand, please. Oh man, this is going to be old news for you guys. All right, so we'll start kind of with an overview of ITP, kind of name changes, TCP, right? And then we'll go into some software-defined networks, kind of what they are, why they're important, and then kind of some of the research that I've been working on just to show you kind of the next phase of what's going on in networks. And before we even do SDN, one thing that Jim may have said a little incorrectly is SDN is not harder. It's actually much, much easier and better and cooler on every sense of that. So we'll get into that as we go. So I'll give you a background on myself first. Please, if you have questions, raise your hand. And then at the end, I'll open it for some more questions, of course. But a general rule for these seminar series, be thinking throughout the series. Me, I'm going to be like the least distinguished one you're going to have the whole semester. But for the real important people, at the end, start thinking to yourself. I thought someone was talking to me. Sorry. Start thinking to yourself about 3 questions. All right. So at the end, you always want to ask a question. Obviously, not all of you are going to ask a question at one time. But just in case you want to have a question, be prepared to ask a question. So today, you can practice as I'm going. Start thinking of a couple questions. If, hey, do you have any questions? You could have something to ask. Okay. Yes, sir.
We also remind you, those of you who are coming in late, that room up there is ECCR 150. It is available, and you will be able to use the microphone to ask questions, etc. For those of you who are standing and want to sit, ECCR 150. 150.
Okay. I'll give them a couple minutes to get up there, but we'll keep going. Maybe that's just backfeed. All right, so let me give you a little background about myself, and then we'll go into kind of overview of kind of the program, what you can expect, why you're here, that kind of thing. So a little on my background. So before I came into academia, I worked in industry. I was a senior network engineer, and I managed the support team at Adtran. At the time, we were number 2 in market share for routers and switches to Cisco. And we were, every year I was manager of the support team, we were ranked number 1 in support throughout the world. So we were pretty happy with what we did. I managed all of the routers, switches, voice over IP, firewalls, every piece of hardware that we supported. I managed all of those networking equipment. And during then, I got my Ph.D. to work in, do research in industry. That kind of led to some other things, and then I ended up here. So with a Ph.D. comes research, right? And so I'm a research associate on the Open Networking Foundation. Has anyone heard of ONF before? So ONF, the Open Networking Foundation, is an open source group of the top operators, right? So Google, Deutsche Telekom, Comcast, Facebook, all of the operators are on this committee, Open Networking Foundation. And the goal is to, if we're going to redefine how networks work, that's what the Open Networking Foundation is doing. Okay, so think of, if we had to start over and redo networks altogether, that's kind of what the ONF started as. Okay, and then the other one that I am a research associate on is the MEF Research Council. It's kind of more focused on operator, internet service provider connecting these. And some of the research I do there, which you'll hear in a little bit, is workload orchestration application. So think of DNS. Some of you have probably heard of DNS, domain name system, right? So there is one standard body that manages DNS for all the domains everywhere, right? So someone manages all domains. What we do for MEF is the same thing. We want to have a platform that manages how all ISPs connect to each other. Right? So think of a SDN orchestration platform that manages all interconnections between all ISPs globally. So that's what I work on there. We'll talk more about that in a little bit. And then some of the research, obviously, well, that's kind of what today's topic is. And then, you know, my hobbies outside of work are mainly all forms of rock climbing and mountaineering. All right, so a little bit about the program. You know, I taught the telecom lab class, which usually Jose Santos teaches. I taught it adjunct for a little while. And at the time, I was kind of vetting the program and being like, all right, let's see what they're doing. And what I found is they run it like a business, right? It's run like a business. People show up on time. The courses are exactly what I was teaching the new hires that I was training. Everything is industry focused. And so that's why I decided, you know, I want to be a part of this. This is something that's really, really big, and it's really going fast. And so I joined that. And with the people back here at Adtran where, you know, I worked, so I managed that team, and I did all the interviews, the hiring, the firing, the reviews. And our interview process at Adtran was for new hires coming in, there was a 1-hour phone screen. Then if they passed that, we would fly them in for a 4-hour dinner interview. And then if they made it through that, the next day would be an 8-hour interview. And each of those 8-hour interviews were 4 people for 1-hour sessions. Okay, so we would have all of our senior level engineers, we would have our managers in and out. And so every technology, the first one would be on switching. The next interview would be on routing. The next interview would be on VoIP. The next interview would be on firewalls. The next interview would be on managerial type situational. So we wanted to see how in-depth, how you handled pressure, what you know, what you didn't know. And I'll go more over those on tactics at the end of the class, kind of what you can do for internships going forward. But all that to say, everything that we were doing there, I saw in ITP, right? So if you think of what we do here, we all focus on hands-on labs. Right? You've seen our labs. I mean, quite frankly, they're some of the best labs definitely in the US, if not the world. Right? And so the hands-on aspect, you just don't get somewhere else. right? And the application process on top of that, like the people in this room, like you're some of the top engineers in the world. So just getting here in the first place is really impressive. And you know, obviously through ITP, everyone got an internship last year. Most people had multiple full-time offers upon graduation. And the people getting those offers, the companies are Facebook, Google, LinkedIn, Amazon, Arista. Every company that you know and love are coming to our department exclusively to hire. So for example, Facebook has told me that we don't interview other schools. We hire only from ITP for network engineering. Okay, I mean, that's impressive for what you students can do after our program. Right, so I can't say enough about it. I think it's amazing. But what we're doing here is we're all hands-on for the network engineering curriculum, right? So the general core courses that we're doing, you know, the routing protocols class is all BGP. The telecom lab, traditional Cisco routing and switching. Everything has Python programming, Linux, network management, and automation. What you notice about these core courses are they've changed over the past few years. And what these are now is exactly what industry is looking for, right? So, for example, Linux has always been around, but recently it's become extremely popular. Does anyone know why Linux is becoming more and more popular? Open source, right? Everything is moving towards open source, right? And Linux is kind of the king of open source. So we focus a lot on Linux. What about Python? Why is Python important? Network automation. We'll talk about that in a little bit. But absolutely right, right? So you have the traditional router and switch CLI engineers like me, but now when you talk about everything at scale, right, we're not talking to configuring 10 or 20 routers, we're talking 20,000 routers. You can't log into each of those devices one at a time and configure them. You have to do that via automation. Okay, and that's where Python comes into play, Linux for the open source. Then in addition to those, some of these technical electives, like you can't get these courses other places. You may get a course on data center networks, but you're not going to be spending 20 hours a week of hands-on data center configuration, troubleshooting, right? It's going to be all theory. Okay? One of the benefits of our program is we're giving you everything about the theory that you want. It's going to be as in-depth as it possibly can, but on top of that, we enforce all of those theories with the hands-on skills. Right? It's kind of a combination that you don't get at other universities. So the other one that we kind of are one of the leaders on is this next generation SDN NFV. And I read every single one of your applications, and I think a lot of you probably typed in SDN, my name came out, so you put it on your application. Oh, I want to take this course under Levi Perigo. I marked your guys' names down who wrote that on there, and I won't forget, so thanks for doing that. All right, so let's talk a little bit about SDN, all right? So software-defined networking, if you think of core network engineering on this side and software development on this side, SDNs are right in the middle, okay? So is it a new kind of technology? Is it a new paradigm? Or what do you think? Yeah, it's really new. We've been doing it here for a long time, but in the grand scheme of things, it's pretty new, right? And so what the traditional network engineering model is, you have your routers, you have your switches, firewalls, whatever the device is. But if I buy a vendor router, let's say it's a Cisco router, Cisco did that software and all those features that are built in are Cisco proprietary. I can't log into a Cisco box and change the code, right? You pay for what comes on that box. Okay, if I buy, let me also throw a disclaimer. I'm going to talk about a lot of acronyms, a lot of technologies you never heard of, but I guarantee by the time you get out of here, you'll know all of this stuff in depth and probably more than you ever cared to know. So if you think of a Cisco router, when you buy a Cisco router, what features does it have? Okay. Probably does routing protocols, right? So it can do OSPF, ISIS, BGP, IGRP, right? All these different features are within routing protocols. It'll probably do some firewall, it'll do some NAT, it'll do some DHCP. But what if all I'm doing is making an internet router? All I need is one static route out to the internet. Well, I'm still paying for the VPN features and the BGP features and all the routing protocols, whether I use them or not. Okay, the other downside of the traditional networking model is if I buy Cisco, right, think of a large ISP like Comcast, for example. If I start buying all my Cisco gear, well, we know Cisco gear works with other Cisco gear, and Cisco sales reps give us a discount for buying more and more Cisco. You get what's called vendor lock-in, right? So if I need to replace something, well, all my other gear is Cisco, I need to buy more Cisco. Okay, or Juniper, or Arista, or whatever the company is, it doesn't matter. But what we're trying to do with SDN is move away from that model. Not because there's anything wrong with those vendors, but think of the computer world, right? What kind of laptop can I buy? I can buy an HP laptop, I can buy a Dell laptop, I can buy an Apple, and then on top of that Dell laptop, I could run Mac OS, I could run Linux, I could run Windows, right? And then on top of that, what apps can I run? You know, I could run Windows Word, I could run Excel, I could run any form, right? But those are three different layers. The physical box you can buy, then you could load any operating system on it, then you can load any applications on it. Does that work in the traditional routing? No, you buy a Cisco router, that's it, right? Or a Juniper router or a firewall, whatever it is. The idea that we want here with SDN is we want to shift that more to the computer model, right? We can use different hardware at the bottom. We can use different operating systems. We can pick and choose what operating or what applications that we want, right? So think of, even the phone is another model, right? I can buy an Android phone, I can buy another physical phone, but my apps will work on either phone, right? You can't mix and match in the traditional network engineering model. So the other thing, so we're moving all the way, we're trying to go more to open source, and then we want to do orchestration, abstraction, and programmability. All right, and all of this goes back to scale. Right? Networks are getting so big that we can't log into each one of those one after another. So if you think of network automation, Vishal, what is maybe important about network automation? Like, what do you think does that do for the company? You mentioned this yesterday in class. Time is money, absolutely, okay? So time is money, right? If I have to log into a device, type these 5 commands in the command line, and then I have to do that 100 times, that time adds up really fast, and they're paying me as an engineer to do that. Okay, well, if I write a script, I push that button and it does it in 15 seconds, now I can use my time for something else, right? So time is money, and when you think about the scale, right, that's where SDN, automation, all of that comes into play. All right, so another benefit of the open source thing is vendor neutrality, right? So vendor neutrality is the opposite of vendor lock-in. Okay? I can choose any vendor I want, I can mix and match vendors, I can write my own application if I want to, a little bit of everything. All right, so what we do kind of here is 4 years ago when we started doing SDN here, we were the only hands-on SDN course in the country. Okay, and so 4 years ago, I think I've been teaching it 2 semesters for the past 4 years. It's changed a lot since when we first started. But kind of what we're focusing on is vendor neutral, right? So in our labs, we focus on vendor neutral devices, right? That way, regardless of where you go, the concepts are still going to be the same. Okay, so for the half of you that are in my datacom section, what I said the other day is, if you know the theory and the technology, it doesn't matter which vendor you're using, what product you're using, it's going to be the same, right? If I know how ARP works, it doesn't matter what technology or what vendor I'm using. If I know how OSPF works, I can figure out how to configure it on a Cisco and a Juniper, right? The technology is the same. So we're going to focus on the technology. And another reason that we just focus on that is SDN is so broad, right? So the people in the NGN class right now, they're working on defining what SDN is because every company, every person does it completely different. Okay, that's the beauty of it. It could just be a Python script. It could be OpenFlow. It could be another application. It could be virtualization. There's so many different ways you can do it. There's not one standard for everything, which is the beauty of it, but it's also really hard to define. So we focus on all the technologies. We do a variety, right? So you've probably, if any of you heard anything about SDN, you know of there's controllers, there's containers, there's a bunch of different ways you can do everything. But all of industry kind of says we need to look at all the different versions because if we're talking about Open Daylight as the SDN controller, right, if that's all that I did here, well, what if I go to Comcast and they're using Floodlight instead of Open Daylight? They're completely different, right? So we need to touch a whole variety of SDN because they change so many ways. So think of SDN as far as in ITP, Netman is SDN1, NGN is SDN2, and Advanced NGN is SDN3. So think of that as kind of the flow of how SDN is in ITP. And another thing that we look at here is certifications. Okay, so you know, in grad school, a lot of people are against certifications, and but the downside is in network engineering, they're required. Right? If any of you have ever looked for a job, most of the job descriptions say CCNA required or Juniper JNCIE required, even before you can get an interview. So the difference of our students compared to everyone else is, yeah, you're going to have those certs too. Like you can get those on your own easily, but you're also going to have hours and hours of hands-on training on top of that. Right? So you're going to be able to blow away all the other candidates in your interview. All right, this is last year's NGN students working on their final labs. So this is obviously our labs are so much more advanced than most other people in the country, but these students have these whole racks for the whole semester. Like they did everything here. It's a nightmare and a disaster. Think about grading this, like it's terrible. But the amount of equipment that you guys get to use, I mean, it's unbelievable. Like I cannot stress to you that this is not normal. I went to a conference, and this is one rack right here. Some of you don't even know what a rack is yet, but this is one rack. Oh, is it not drawn on the screen? Oh, I'm so sorry. Oh, it's just a different color. Sorry. Thank you. Well, there's so many colors in this one. Let me do it like this. This is a rack. All right, so this is a rack. I met with this conference, and it was an SDN conference, and I was telling them about what we did here at ITP, and we have about 20 students in our SDN class. They had 80 students in their SDN class, and they had one rack for all 80 students. We have a rack for each student. Right? It's just like, it's unbelievable. It's such a competitive advantage that you guys have compared to everyone else. But the thing is, you got to use it, right? I told this to the Datacom students the other day. You don't just blow through the labs to get your grade. Take some time, go above some of the different exercises, spend some extra time, because this is the time you have to do it, right? You're in grad school. There's no time pressure. You're not going to get fired if you don't get it done. This is the time you can learn, add more, build your skill sets, and set you apart from everybody else. All right, so let's start kind of with an overview, and then I'll tell you some of the research that we're doing. So software-defined networking, right? We got an overview of what that is. Network functions virtualization. Does anybody know what that term is? You've heard SDN before, right? Have you heard NFV maybe? A little bit? Not really? Okay. NFV is taking a network function, right? A network function could be a router, a firewall, a VPN device, or it could even be smaller than that of BGP code, right? So usually you think of BGP inside of a router. Well, we can virtualize a router, or we can virtualize a function of that router, DHCP server, DNS server, whatever it is. The concept of this is taking it, instead of it being physical hardware, we're just going to make it virtual software. And the benefit of that is we can put it wherever we want. Okay? And we can put it on any platform that we want. Okay, network automation, we'll talk about in a little bit, and then DevOps. DevOps is, development and operations, right? This is a really key part right now. Operations, think of that as kind of your traditional network engineers, right? They're operating the network. They're managing the network. They're starting servers. They're configuring routers. Then you have your developers who are writing software and applications. So the term of DevOps we want to blend these two together, right? Which is what you, as ITP graduates, become, right? You know core networking. You know a little bit of software. You know systems. You can put it all together. So you essentially become DevOps engineers. Okay, so we'll talk about some of my research on these different ones. All right, so this is an ongoing one. So visualization, right? The concept of visualization is taking some software, taking some network things and visualizing it to make it easily understood. Intent-based networking is being able to say something on a very, very broad term. Okay, so think of it like a car. Right? I sit in my car, I turn the key, the ignition starts, the fuel starts. I don't know anything about that. All I know is I turn the key and it starts. All right? So an intent would be, all right, I turn the car. That would be more abstraction, right? So if I want to abstract something, I sit in there, I turn the key, I don't know what's going on behind there. All I know is I'm turning the key and my car starts. Right? But there's a lot that happens behind the scenes when you turn that key. Okay? Intent-based networking is, think of like an airplane, okay? I get on, I sit in my seat, I go from Denver to Chicago, right? I don't tell the pilot what to do, I don't tell him how to fly the plane. All I say is, I want to go from Denver to Chicago, I sit in my seat and I get there. Okay, what we did here is we did that same thing, but we did it all with a voice. Okay, so we used Amazon Alexa and we said, hey Alexa, I would like to configure the fastest route from Denver to Chicago. Okay, and then I keep wanting to say she, but it's not really she, it's just software in the background. Alexa would go in and configure all the devices between here and Chicago. She would find out which ones were the lowest, the fastest ones, configure all of that. All I did, I set an intent, right? I said, the fastest path from Denver to Chicago. That was my intent, okay? It was abstracted to me as well, because I don't care what happens on the lower layers. And then Alexa took that, converted it to Python code, logged into all the devices, configured them for their routes, their routing protocols, their SDN, OpenFlow, flow tables, all of that from point A to point B. And all I did was say, Alexa, configure the shortest path from Denver to Chicago. Okay, that hasn't been done before. A lot of people are using Alexa to turn their lights on in their house, right? Or tell me what the weather is. But to use it for something as advanced as configuring 100 devices, right? Nobody uses it for network engineering. Can you think of like the benefits of that, right? You just say what you want to do and Alexa does everything else for you. Now, can you think of any problem with that? That's a legitimate question I want one of you to try and think about answering.
Security.
Okay, so what is maybe a problem of I walk in and I say, Alexa, configure 100 devices between Denver and Chicago and make it the least amount of hops?
Authentication.
Go ahead.
So we won't know if something goes wrong, then we won't be able to troubleshoot it, as we won't know which layer the problem is occurring.
Okay, so troubleshooting becomes really hard. Absolutely. Okay.
Authentication.
Authentication. Okay, absolutely. So security could be a huge vulnerability, right? If anybody can walk in and say, hey, Alexa, take down the entire network, she can do that, right? That's really, really bad. Okay, so we added two-factor authentication, right? So you had to log into the web interface. You had to, whenever you talk to Alexa, she would wait and say, I need you to authenticate. It would come to your phone, you type in your 2-digit password, then you could do everything, all right? So when you start thinking about research, there's some really, really cool topics. you always got to think about security as well, okay? So in addition to that, we found it took about 0.08 milliseconds to configure a device, all right? And so since everything is via software, it took 30 seconds to interact with Alexa. So we would say, hey Alexa, she would reply back, and then we would say, what do you want to do? Here are your options. Okay, we want to go the fastest route. Okay, which cities would you like to go to? This city and this city. You know, by the time we did all that, as soon as we finished, it took about a quarter of a second to do it, but it took 30 seconds to do it. But the point is, it takes 30 seconds, and then after that, whether it's 2 devices or 2 million, it's done within seconds. And the user doesn't know anything other than, I'm just talking back and forth to Alexa. Okay, it's a big deal. It's really cool. And then what happened was whatever kind of the troubleshooting part was, whatever Alexa configured, it would pop up on a web user interface and show you, here's all the devices I configured, and here's the green route that I took to get there. Right, so it gives you that feedback of, okay, I told her to do this. How do I know if anything ever happened? Well, that's where the visual representation comes in. Right? It would pop up on the screen and show you, oh, yep, here's the path that I took. Everything's going just fine. Okay. Another one that we found, and so the technologies we use were SDN, Python, OpenFlow, containers, and BGP was mainly what we used for all of this, if you want the actual technology. What we're kind of focusing more on this one, is you'll see in a little bit, is we're adding more to this one. But here's another project that we're working on. So most of these projects I've either published on, or they're currently submitted, or we're working on them with research students, master students in ITP right now. All right, so the self-healing network is another one. Right, so most of you have probably heard of machine learning. Right, so there's multiple ways to do self-healing networks. What we did is we ended up fixing about 20 different things. Okay, we wanted to start on a very small scale. And the point of this is, it doesn't matter. You don't have to fix everything at once. Right? You're never going to be able to fix every problem. But what if we focus on maybe the top 5 problems or the top 10 problems and go from there? Right? So if everyone troubleshoots in their own way, absolutely, right? It's kind of an intangible skill for sure. But we do the same similar things. If a port is down on a switch, all right, log in, is the cable plugged in? Is the shut down? Are there errors on the interface? Right? If we troubleshoot by these same 10 or 20 steps, why can't I write a script that does that same thing? Right? So, and you can't always fix everything, but like on a link down, for example, this kind of top one up here, right? So link downs are easy, right? There's a few things that could be wrong, right? Is the interface up? Is the interface down? Is it plugged in? Are there errors? Has it worked before? But there's also easy things you can do to troubleshoot it, right? I can try and type shutdown, no shutdown, right? Try and bring it back up. I can do a loop back and have it go out that interface and ping myself and see if that works, right? So what the self-healing network's going to do is, let's take some of our top things, see if we can try and fix some of them, right? If it fixes itself, that's great. If it doesn't, we can then take a list, send it to the network administrator and say, hey, switch number 99, port 1 is down, here's the 10 things I've tried to fix. All right, so then I can go in there and I don't have to check those 10 things, right? Because we're always going to check those first few things over and over, but if I already know they've already been checked, this is what's been done, I don't have to do that over and over, I can start somewhere else. Okay, now what becomes really difficult in a system like this is what prevents you from breaking something else while you're actually trying to fix the same network, right? So let's say for me to fix something like an OSPF neighbor issue, I need to bounce that link, right? So let's say the OSPF neighbor, you may not know anything about OSPF, but let's say our hello timers are mixed matched on OSPF, therefore that OSPF neighborship isn't forming. Okay, well, how am I going to troubleshoot that? All right, I'm going to log in, I'm going to look at the code, I'm going to see, all right, what are the hello timers set for? What do the debugs look like? Is the interface up? Are the MTUs the same? Those kind of things, right? So I can troubleshoot all that. Okay, but if that doesn't work, I'm going to shut that interface down and bounce it back up. Okay, but if my code does that, well, now an interface is down. So now my link down code starts. Okay, and each thing leads to another, and you get into this loop of one thing tries to fix something, which breaks something else, which tries to fix itself, and then breaks something else. Okay, so with self-healing networks, it becomes this super involved, complex thing. But what we're trying to do is just start at the bottom, right? If we can get some of it to work, then yeah, we can move on and work on some other things. So what we did, we ended up fixing, probably 15 or 20 things. The results of this research were we found that fixing things in a traditional network are extremely, extremely harder than a software-defined network. Okay, same thing on this voice one. Doing all this with traditional boxes, it just took too long, right? For me to automate traditional boxes, most of the time we're either going to use an API or we're going to SSH in. If you have to SSH in, you got to get IP connectivity to it, you got to log in, you got to send a username, you got to send a password, you got to wait for that to establish. Right? By that time with SDN, we'd already configured 1,000 devices before they even logged into one of the traditional ones. Okay, same thing here with the self-healing. Right? We kind of separated this into two separate sections of a self-healing network. Okay, so we fixed a few things on the traditional network and we fixed a few things on the SDN and some that were both. Okay, so for example, one that we did down here, you can't really do this very easily on a traditional network. And actually all the NGN students will be doing this as a lab later this semester. But for example, if we can find a host that's attacking our system, okay, whether we match the MAC address or the IP address or whatever it is, if we can find that, right, what our self-healing network did is it recorded that. So first, we had to match that it was an attack. Okay, so when we find that it's an attack, we record the IP address and the MAC address. Okay, why would we want to record both of those? Any ideas why we would record the IP address and the MAC address? Go ahead.
So when we are actually coming from a top-down approach to finally get to the this thing, the device which is actually the host which is actually acting as the maybe a man in the middle attack, we need both to identify it.
Okay, so good, for sure. Good.
MAC address is a unique address, but the IP address can be same for other.
Yep. Okay, so absolutely. All right. So what he said was MAC address is unique to the device, and technically it is unique. We can get around that. But IP addresses can change, right? For all of you in Datacom, we'll be doing this in about 2 weeks, right? MAC address, IP address. For those of you looking at me like I have no idea what a MAC address is, we're going to be doing all that coming up, right, in Datacom. So what we're doing is, what we did is we matched that it was an attack, okay, and then we said record that IP address and that MAC address, put them together, so now we have a malicious host. What we did then throughout the entire network is we blocked that MAC address from doing anything on the network, and we sent an alert to the network administrator, right? You could possibly do that in a traditional network, right? I mean, this may be getting a little more in-depth than what you want, but we have our malicious host, right? We got our switch, we got our router, let's say we got some other switches, right, etc. Okay, if we want to block a host on a traditional network, where are we going to block it? We could block it on a switch, yeah, but where do we usually enter our firewall rules? Either on a router or a firewall, right? We use access control lists. We could use port security on the switch, right? We could do that too. But usually firewall type rules are going to be on a router with access lists, right? Well, if we put all of our ACLs for our malicious host on the router, they can still talk like this to other hosts. They could still be malicious within the network, right? But with SDN, we could say, find this host, block it throughout the entire network. right? Regardless of how many routers, regardless of what vendor they are, regardless of if they're a layer 1 device, layer 2 device, or, well, not layer 1, layer 2 or layer 3 devices. Okay, everything becomes so much easier with SDN. Okay, we got a few more here. Okay, so this is one that I recently just published a paper on. But the concept here is using everything to make things easier. Yeah.
How would you confirm it's an attack?
Okay, so it's just a different, there's certain algorithms. Good question. Snort is a popular tool to make alerts and find attacks, and you can train it in a certain way. So we would make snort rules that would catch certain attacks, and then we would take those attacks, have our script run against those, and then apply all those filters to all the end devices. Yep, good question. For time, I'm going to skip this one. I got a couple more I want to talk about. So this is another one that we did. So you've probably heard the term of big data analytics. What we did here was we used traditional network devices and software-defined network devices, and we did trend-based networking. All right, so we're pulling information off of these devices. Some of this, you guys are looking at me like this is super boring stuff. To me, I couldn't be more excited about it. But the thought is, by the end of your degree plan here, you're going to be able to do all this stuff. You get to choose what you want to do. All right, you can be as technical as you want. You can be more security or wireless or policy. But this stuff right now is just, it's really hot in the field. And you can just, whatever you can think of, literally you can do. Right? If you can program it, you can do it. All right, so that's why it's just so cool right now. But what we're doing here, just quickly, and then I want to do the one other one after this, is, right, if we can analyze data, right, if we're capturing all this information from the traditional network, interface statistics, CPU utilization, how many times an interface has gone down, if I can track that and store it in a giant database, I can then start querying that to see trends. Okay, and what we found was, we set this all up and tested it, and we kind of created a scenario that on Monday, from the hours of 1 p.m. and 3 p.m., these devices see a whole bunch of traffic, right? People are coming back from lunch and they're browsing the internet, right? So traffic spikes at that time. Well, if we can see that happens every Monday at those 2 hours for the past 2 months, I can start making preemptive decisions on that, right? So I can say, oh, it's Monday between the hours of 1 and 3. I know my traffic's going to spike. So what we can do then is say, all right, start analyzing all this big data. All right, we found a pattern. And then we can say, let's make a decision based on that. All right, so now we know what it is. So now from the hours of 1 and 3, we're going to route traffic a different direction. Okay, and then we capture all that data and then start all over again. So we can optimize everything based on how our network is working, right? Based on the trends. Whether that trend is 5 minutes, 5 hours, or a year, right? The concept is if we can map these trends, we can start improving on things dynamically and we don't run into problems. Okay? I could probably talk on each of these products for like a whole semester, but I'm trying to go pretty quickly here. The last one that I'm really excited about is what we're currently working on. This is like hot off the press. And what I try in all of my classes for sure, the network management class, the software-defined networking class, yeah, you're going to learn some skills. Yeah, you're definitely going to learn the technology. But absolutely number one most important thing is being able to think outside the box, right? Because Cisco routing may not be here 10 years from now. Programming, Python may not be here 10 years from now. But if you can learn to think about things differently, right, you're going to be very valuable in whatever role you are, whether it's pure network engineering, where it's management, right? So I want you to start getting into that mindset of thinking differently. All right, so what we're currently working on with software-defined networks is right now everyone is using software-defined networks, right? Google's a big advocate of SDN with OpenFlow and these technologies, right? Well, if we focus on the same issues that they're doing, network engineering, software-defined networking, that's what everybody's doing. But if we take software-defined networking to maybe an area that it isn't being used for, like power efficiency or green power, right? This is a whole new area that, well, we don't think we could use SDN to do that, right? But if you start thinking of what we can do now in all the ways that SDN fixes the power issues, right? So think of, we talked a little bit about NFV, right? Network Functions Virtualization. Well, if I have these virtualized functions, I don't have a router in my rack that I have to power, and a switch, and a firewall. They're all virtual inside of a server, right? And that server usually already has some power save mode, efficiency, so we can start to save power there, right? Think of it as sending boxes to customers, right? So Comcast, the ISP, right? If someone buys Comcast Business, they send them an Adtran router, they send them or Adtran VoIP box, they send them a Cisco router, all on site, right? Well, what if we host all of those physical boxes as virtual boxes in the cloud, right? Now we've removed all that power from the end devices. We're saving that much power. Okay, the other thing we can do, that's reducing actual physical power consumption. What we just kind of created is, Rahil is I guess none of you first year guys will know him, but he's my Ph.D. student. What he's working on right now is green path forwarding. So we can make routing decisions based on if a data center is green powered or not. Right? So think of, we have several different paths to traverse. Okay, well, if this data center is green powered, I'm going to route my traffic to them. Okay, whether that green power is the physical boxes inside of that are powered more efficiently, or if the entire data center is powered by renewable energy. Right? Two very different things. But we can give priority to which one we route to, okay? So then think of the cascading effect of that. Okay, so now if we're choosing to route traffic to green data centers, that means more data centers like that will form because more people want to be in that because more people are sending their traffic there. So then it just cascades to now more and more green data centers are going. So the power consumption and energy consumption kind of cascade down. And just like that, we've changed the world, right? Okay, so that is it. I want to save a few minutes for questions because everybody's been thinking of their 3 questions, right? If I called on you and you had to ask a question, you should have had some kind of thinking about. So those are some of the projects we're working on. That's some of what we do here at ITP. Hopefully, just starting off, the main thing I want you to think about is like, you're in the right place. This is super exciting. Most of you have a year or 2 left. So just use it the best that you can. Okay, what questions do you have? Please raise your hand and I may call on you. Yeah, go ahead.
Out of the blue question. So you just told us about the NFV, right? So network. So if I'm having a server and they're having a virtual router on it, will it affect its efficiency? So
Man, that is a fantastic question. So one of the capstone projects that we're working on this year is exactly the question that you had, right? So his question is, if we have these virtual functions, right, how does that work efficiency, right? Does it take more CPU cycles? Does it delay the throughput? What if we have multiple functions that all chain through each other, right? Whereas if I have a Cisco router, if I'm doing DHCP and firewall and routing, they're all in the same physical box. Okay, but when you start getting into hypervisors, orchestration, virtualization, even though I'm saying go to this DHCP pool and then this router and then this firewall, those functions don't have to be on the same server. They don't have to be in the same data center. They don't have to be in the same country, right? So all of those different functions really, really could damage throughput, but we have a capstone project, which all of you probably will be doing a year from now on that exact topic. So yeah, good question. Anybody else?
Something goes wrong, like if you encounter a bug, who's accountable for fixing it?
Oh man, that's an outstanding question. All right, so if you run into a bug, who is accountable for fixing it? It is a nightmare right now, right? Because the whole benefit and the whole exciting thing about SDN is I can have this vendor for this vendor for this. I could have my own software that I wrote do this. Okay, but what if there's a bug? Whose problem is it? Is it interoperability? Is it a bug in my code? In addition to that, that's not even with SDN, that's open source in general, right? If there's a bug in open source, is it fixed within a day or a year or never? depends on us as the open source community, right? If I get a bug at Arista, they're going to have a software cycle every 4 months or 6 months or whatever it is. So that's a great question. The answer is it can be terrible or it could be really easy. Depends on what it is. Anybody else? We got another couple minutes.
So you talked about power consumption. So if we are virtualizing physical boxes in servers, then we need to have that server that much powerful if you are virtualizing that router.
Yep.
So that server will also consume that much energy, or that?
Yep, so great question. So the concept is now we've taken a virtual router that we would have a physical box and we're powering it, right? But now we've taken that virtual software and we've moved it into the server. Okay, but how much does that increase the power consumption of the actual server? Okay, outstanding question. There's no research on that right now. But generally the overall thought is a server can handle software much more efficiently than a full box that's powering fans just for that one dedicated. So if you think of it on a scale, right, my server can run a piece of software a lot more efficiently than a box dedicated to do that same thing. But the answer is there's not results on that. Yep, good question.
How do you differentiate between a data center which is powered by a renewable source of energy as compared to a traditional data center with power efficient?
Yep, great question. Yep, great question. So when we're talking about choosing one data center over another based on if it's green or renewable power resource, how do we determine that? Okay, part one is with SDN, you can do it however you want. It doesn't matter. There's no rules, right? You can do whatever you want. Okay, the other way is with BGP, right? We can mark a spec within BGP that tags it when it goes out. So then when BGP is the standard routing protocol kind of for the internet in between data centers, so we can do it with BGP. Yep, good question. Okay, one more question from a second year student. Oh man, she's already ready. Yeah, Simran.
I have a very specific unit-based question. So
Okay.
the initial time is 30 seconds right now. How accessible is Alexa?
Okay, so great question. So with the kind of VivoNet one that we did, I said it took about 30 seconds. The main reason it took us 30 seconds was just our interaction that we configured her for, right? We could just say, Alexa, do this, and she would do it immediately. But we did several different options kind of to narrow it down, make it more kind of what we wanted. So really it was more, there is a delay. You can, this is really weird. We tried this too. You can change how fast she speaks to you. Right? So we would say VivoNet or launch VivoNet, and then you just like speak and you couldn't even hear what she was saying, right? Or you could make it's super weird. Like you've heard her talk and she's like, hello, I'm Alexa, what would you like to do? Or you can have her go, hello, I'm Alexa, what? Yeah, it's really weird. So you can have her go really fast, really slow. The majority is you can change a whole lot of Alexa's code. Yep, great question. Okay, so I'll be happy to answer any other questions. The main thing I want you to think is all of you in ITP, it's a super exciting place. And right now, the field that you're in could not be more exciting. Like, I wish I was in your guys' shoes. So that's it for today. Thanks, everyone.
So let's thank our speaker, please. So thank you very much. Here are some next steps. There is a homework assignment which is due tomorrow, I believe by midnight. You are to write 1 page about what you have heard. That's all. And you are to submit it through Canvas. The reason why I'm asking you to do that is because I want to learn from you. I don't understand what software-defined networks are. I don't understand 90% of what Professor Perigo said, but guess what? You will, and it will be on the test tomorrow. And so thank you all. Please write 1 page. Please submit it. And thank you. And next week, we have a director from the National Institutes of Standards and Technology. His name is Keith Grinbram. We will post the necessary information, and we will meet in the DLC 170, Discovery Learning Center 170. Thank you very much, and have a good evening.